So I just realized these notes had no audio. So guess who gets to redo them? This guy. This is 2.6, the quadratic formula. To make this quick, I was trying to get 2 or 3 days ahead. Quadratic formula, and I'll sing it to you, goes x equals negative b plus or minus square root b squared minus 4ac all over 2a. I had a kid a couple years ago who said he didn't understand the song and how to write the formula. So I gave him the lyrics, and then he dropped out about 2 days later. But it's x equals, let me make that text bigger where you can see it. Poor kid, he didn't last too long. It's x equals negative b plus or minus square root b squared minus 4ac all over 2a. If you need the lyrics, there they are, okay? Yeah, he didn't last long. Of course, he had other issues. He had anger management issues. He was mad at everything. All right. So anyways, that's the quadratic formula. The discriminant is the stuff inside. It's the b squared minus 4ac part. And it tells us the nature of the solutions. And we'll get to that in a little while. All right, so how can you use the quadratic formula to solve quadratic equations or to predict the nature of their solutions? This one is simply about picking out A, B, and C and plugging them in. A is 3, B is -4, and C is -9. And, write this thing down until you know it. It's x equals negative b plus or minus square root b squared minus 4ac all over 2a. Formula retention's a big deal. It is, and I don't know how to fix that. I can give formula quizzes, but they're so depressing to grade that I just don't do it anymore. But we're just going to plug into it. So -4 is going to be 4, right? Plus or minus square root. If you're going to square a negative, you should wrap it because most of you are button pushers. And there's nothing wrong with that to some degree. But if you are a button pusher, make sure you know how to push buttons correctly. And it's all over twice A. So hopefully you understand where the numbers came from. Like this was B, that was negative B, that was A, that was C, that was A. You're just plugging stuff into a formula and nothing more. All right, let's crank out the math here. Do not type in the square root symbol on your calculator in Algebra 2. I don't want your decimal answers unless it's a real world problem. This is going to be 16. A negative times a negative is a positive, so it's 16 plus something, right? 4 times 3 is 12, times 9 is 108. And if you put those together, you get what? 124. Now, I know you don't believe me because what do you mean? A person can do math in their head? What? What kind of crazy stuff is that? Like, who would have thought? Just because you can't seem to do it doesn't mean that I can't do it. But perhaps you should work on that because I promise you, you could if you wanted to. 124 is in the radical. And it's all over twice A. 2 times 3 is 6. So here's a tough skill for most juniors every year. Simplification of radical. I do not want your decimals. I could call out some names right now of kids that I already know will type in root 124 in your calculator because you don't have any number sense. 124 is divisible by 4. And the kids who make good grades, they don't necessarily know their multiplication tables. They literally just go to their calculator and they push buttons. But I know it ends in a 4, probably divisible by 4. It is the root of 4 times the root of 31. And the square root of 4, I hope you know, is 2. So this changes into 2 root 31. I want you to notice that both pieces are over 6. So we're going to write 4 over 6 plus or minus. I have replaced root 124 with 2 root 31 also over the 6. And I'm going to keep performing reductions. 2 over 3. And 2 over 6 is 1 over 3. So plus or minus root 31 over 3. A big question is here is what are these solutions really? Like, what are these things? What are these x values? Pause, take a second, think, use that brain of yours. What are these things? Okay, that's the question. What are they? Why am I finding them? Right? Well, A picture is worth 1,000 words. 3x to the second minus 4x, I think it was minus 9. So Desmos and a TI-84 is not going to give you simplified radicals, but there's that 2.52259. And I told you that it was 2/3. One of them was root 31 over 3, I think. Well, apparently it wasn't. Let's go back there. 2/3 plus root, oh, duh, dum-dum. Did you catch the mistake? Because I see it plain as day. I did not hit the arrow out key, did I? There we go, 2.52259. So these solutions are nothing more than x-intercepts. And, there's some vocabulary here. We call these zeros because they were set equal to 0, x-intercepts, and we also call them roots of the graph. They are the roots where you enter the ground beneath. All right, how can you use a quadratic formula to solve x squared minus 9x plus 27 is equal to 0? Hopefully you understand the understood by now. A is 1, B is -9, and C is 27. And again, write the thing down. X equals -b and sing the stupid song. Plus or minus square root b squared minus 4ac all over 2a. A lot of kids tell me that they don't hear themselves sing. It's me that sings. You poor kids, you let me in your head. You're in trouble now. Opposite of a -9 is a +9. Remember, if you're going to square a negative, it is good, safe practice to wrap. That's a true lesson in a great many things in this world. Always wrap. And let's see, C is 27, all sitting over twice A, and A here was 1. I plugged in A, B, and C. And now I'm going to crank out some math here, okay? That's going to be an 81. 4 times 27, I feel like that's 108. And it is. So plus 108. And if I put those together, I think I have 189, which, believe it or not, is a square. But, I know you don't believe me, so can't trust the math teacher. What's he know? A lot more than you think. Oh, that was a negative, wasn't I? Oh, you shouldn't trust the math teacher. That's supposed to be a minus. Oops. That's what happens when you talk smack, isn't it? Did I type everything in right? -27. All right, so we got 9 plus or minus root -27. Both pieces over a 2. 2 times 1 is 2. Okay, so from the other day, the root of -27, is it real or imaginary? It's imaginary, kids. It's I roots of a +27. Now, again, it's radical simplification. It's not meant to be hard. The issue is we don't know our multiplication tables. We have the I. A root of 27 is a root of 9 times a root of 3. And a root of 9 happens to be 3. And it looks kind of silly to write it like that. So we say 3I root 3, or we say 3 root 3, and make sure the I is outside of the radical. I'm a big fan of this notation. So moving forward, we have our 9/2 plus or minus the 3I root 3 over 2. And you really should realize that you have two answers here. Some kids don't. One of them is 9/2 plus 3I root 3 over 2. And the other one is 9/2 minus 3I root 3 over 2. Now, what's interesting is, what are these to the graph? First off, they're imaginary, right? They're imaginary. So does this graph actually have x-intercepts? Plus 27. There we go. And no, it doesn't. You'll notice that it didn't have any x-intercepts. It has solutions, but they're not real, okay? They're not real solutions. Anywho, moving forward. I'm halfway done. Let me pause for a second. Hopefully this thing is recording. Am I talking? Good. Cannot believe I wasted so much time. So we have a compare and contrast problem up here. Here's the deal. Factoring is fast. If you can factor and something appears that it factors, you should factor. If it doesn't look like it factors, then you should probably do the quadratic formula. That's how it is. And some kids, quite honestly, even though factoring is a big deal, you're just going to have to do the quadratic formula. But let's try to factor first. So to make a 6x squared, I probably want a 3x and a twice x. To make a 20, probably a 4 and a 5 would be my guess. I believe it looks like this. What do I know? So let's check me. That's a negative 12x, and that's a not what I want. Apparently I don't know anything, and I see why. Let me erase that. So anyways, this wasn't working because that's a 10x, and I want a negative 7. Because I'm an idiot. Those are in the wrong place. I had something else in my head, apparently. 4 and 5 there. Now the outside makes 15 and the inside makes 8. And I want the 15 to be negative because negative 15 plus 8 is the negative 7. And as by a zero product property, by the ZPP, 3x plus 4 is a 0, or 2x minus 5 is a 0. Subtract the 4, 3x is negative 4. Divide by 3, x is negative 4/3. Or add the 5, 2x is 5. Divide by 2, and x is 5/2. Now I kind of screwed that one up, so factoring didn't seem that fast. QF, you pick out A, you pick out B, you pick out C, and then you just plug it in. And by God, write the formula down one more time. X equals negative B plus or minus square root B squared minus 4AC all over 2A, and sing the song. It's how you remember the thing. Sing the song. It's to the tune of Row, Row, Row Your Boat, and you get to hear my magnificent voice. Anyways, plug in. Opposite of a negative 7 is a positive 7, plus or minus square root. Good practice to wrap negatives. Minus 4 times A, which is 6, times C, which is negative 20, and it's all sitting pretty over. Twice is 6. All right, twice is 6 is a 12. We have 7 plus or minus. 4 times 6 is 24, times 20 is 480? Plus 49 here should be root 529. Now let's check me. That was a negative 7. Notice, like, I'm not typing in the square root symbol. Minus 4, got the 4, times a 6, times a negative 20, and you should play along, kids, but you're not going to. 529. Now, I happen to know my squares, so I know that this is something that has a square root. It's 23. So x is going to be 7 plus or minus 23 over 12. And as small as these numbers are, we can do it. 7 plus 23 is 30. 7 minus 23, what's 7 minus 23? If you're thinking negative 16, you are correct. Do reduction, both divisible by 6, that's going to be 5/2. Do reduction, both divisible by 4, that's negative 4/3. And there's your two x values. Now, as we've been doing this, we have run across, well, there's an example that wasn't in here, but we ran across things that didn't have answers and things that did have answers. So I think the note should be getting ready to talk about the discriminant. And they are. Consider the following equations and draw a rough graph based on what I show you in Desmos. And we're going to be deriving some things here. All right, so let's take a look at our first one, 2x squared minus 7x plus 3. Was that plus 3? It was. Now, what's interesting about this graph is it has two nice answers. So you need to be drawing a graph that has two nice answers at 1/2 and 3. It does factor, by the way. I'm not too worried about where the vertex is, but there she is. It had two real solutions. Now, let's take a look at the discriminant. It wouldn't kill you to write that down one more time. The discriminant is the b squared minus 4ac part. So let's plug into here. A is 2, B is -7. This isn't rocket science. C is 3. Doesn't take that long to pick them out. So the discriminant would be a -7 that's squared, minus 4 times 2 times 3. That's going to be 49 minus, what, 24? Is that right? 4 times 2 is 8, times 3 is 24. 49 minus 24 is 25, which is a positive number. This is positive, which means it's bigger than 0. So there's a rule about the discriminant. If b squared minus 4ac is greater than 0, there are two unique, because they are different, real solutions. So make sure that you're writing all of that down. All right. Next up, 4x squared plus 12x plus 9. I think this is what we call a touch. It looks like a perfect square to me. 4x to the second plus 12x plus 9. It should touch the x-axis at what? Negative, boy, I'm wore out. 3/2. And there it is. Negative 3/2. So we have a parabola that touches the x-axis. Perfect squares do that. Now let's take a look at b squared minus 4ac again. B is 12. 12 squared minus 4 times a, which is 4, times c, which is 9. And that's 144 minus, turns out, 144, which is 0. So this has one repeated solution. This solution actually happens twice, and I'll explain why it happens twice. But if b squared minus 4ac is equal to 0, there is one repeated real solution. Now, why am I saying it's repeated? Well, there's a relationship between how you touch a graph and how many times a 0 happens, okay? These were crosses, and they happened once, and they were both different. Think about how this thing factors. It factors as 2x plus 3 times 2x plus 3. That's how she factors. And you know, if we use a zero product property, we get negative 3/2 twice, don't we? That's why it's called a repeated solution. There is one, and I misspelled one repeated real solution. And the last one here is missing a number. So let's just put a 4 there, because I think that'll make it work. I feel like it will. Let's find out. X squared plus 2x plus 4. Yeah, it worked out. You'll notice this doesn't cross the x-axis, so therefore it has no real solutions. That's the big thing. It had a vertex at, looked like -1, 3. And it looked like that. So it does not cross the x-axis. Therefore, there are no, and the emphasis is on real solutions. Again, let's take a look at b squared minus 4ac. 2 squared minus 4 times a, which is 1, times c, which is 4. This is 4 minus 16, which is -12. And that's the big deal. It's negative. And if you're negative, you are less than 0. So, if b squared minus 4ac is less than 0, there are two non-real solutions. Having fun yet? All right, interpreting the description. Rachel is about to serve and tosses a tennis ball straight up in the air. Maybe you've played tennis, that's how it works. Your textbook made a mistake on the equation, but we're going to go with it anyways. Will the ball reach a height of 4 meters? So that's height, kids. It goes there. 4 equals -5t squared plus 5t's plus a 2. we're going to set this thing equal to a 0. Normally I would shift this thing left, but I'm not too worried about it. Hopefully you understand that 2 minus 4 is negative 2. And A is negative 5, B is 5, and C is negative 2. And we're going to plug into the discriminant, b squared minus 4ac. We're going to have a 25 minus 4 times a negative 5 times a negative 2. Sorry, that was 5 squared, which is 25. Anyways, a negative times a negative times a negative is still negative. We're going to have minus, what, 40? And we're going to get negative 15. So what I just discovered is that b squared minus 4ac is equal to negative 15, which means that b squared minus 4ac is less than 0, which means there are no real solutions. So will the ball reach a height of 4 meters? Most definitely not. Only if you use imaginary things to do it. All right, according to the model of Rachel's serve, will the ball reach 3 meters? Well, we're going to do this the same way. We're going to plug in a 3. And I really did not like that I shifted everything right on the last one. It bothers me. I like to keep my t-squareds positive, so I'm going to shift everything left on this one. So that's going to give me positive 5t squared on the left, minus 5t, 3 minus 2, last I checked was 1. And I've got the 0 on the right-hand side now. A is 5, B is negative 5, C is 1. So this is B, a negative 5 squared, minus 4 times A, which is 5, times C, which is 1. This is 25 minus 20, which is 5. So b squared minus 4ac is actually bigger than 0. And if you just go back and look at the rules that you wrote, this means this is a parabola that crosses the x-axis like she's supposed to, right? So there are 2 unique real solutions. You know, what she's doing is she throws the ball up in the air, and then the ball comes down. She swings at it, and she swings at it on the downward path. And yes, it hits 3 meters. So yes. All right. There was supposed to be an 8th problem, but there's not, so lucky y'all. What values of b will cause 2x squared plus bx plus 18 equals 0 to have one no solution? This is true if b squared minus 4ac is equal to a 0. That is the situation, that we equal 0. So let's just plug in a, b oddly enough is b, and c. So we're leaving b as b. B squared minus 4 times a, which is 2, times c, which is 18, must equal a 0. Okay? 4 times 2 is 8. 8 times 18 is 128. I'm missing something. 4 times 2 is 8. We'll have 80 and 64. It's 144. B squared minus 144 is nothing. You could solve this by factoring if you wanted to, but I'm not asking you to. So b squared is 144 because you counteract subtraction through addition, which means that b is going to be, don't forget this little guy, plus or minus the root of 144, which means that b is plus or minus 12. So if b is either one of those two things, we're good to go. If you don't believe me, you know, question everything, right? What was that? It was 2x to the second. We put in 12x, and then I think it was 18. My God, one solution. If we make that 12 a negative, by God, one solution. Huh. I knew something after all. All right, next up, 2 non-real solutions. This means that b squared minus 4ac is less than 0. That's all it means. B is still b. Take away 4 times a, which is 5, times c, which is 5. Less than 0. It's an inequality. That gives me b squared minus what, 100? That seems right. Less than 0. And I'm going to factor this one. It's b minus 10 and b plus 10 because factors of 100 are 10 and 10. They have to add up to be nothing. Less than 0. Now, inequalities don't work the way you think they do. They don't. Like, you can't say b is 10 or b is negative 10. That's nonsense to an inequality. An inequality has an infinite number of solutions. So let's take a look at this. We came up with what? Well, we'll just leave it in the factored form. I need to be using x's on decimals, forgive me. X minus 10, x plus 10. Less than 0, boys and girls, is when you're below the x-axis. That's what it is. Now, what's cool on decimals is you can just do that. That's where you're less than 0, as long as x is stuck between -10 and +10. This is a true statement. So from the graph, I learned that x was stuck, or not x, in this case, b was stuck between -10 and +10. If I'm a set builder kid, all values of x such that, all values of b such that b is stuck between -10 and 10. If I'm an interval kid, just -10 to 10 does the job. And that is a retake of this same video. Probably a little shorter this time, which y'all don't mind. Oh yeah, it was shorter.